this topic is Industry 4.0, Lean Six Sigma. You see that Michael has quite a bit of professional experience and senior leadership across a few different industries, continuous improvement, quality assurance. You see that there's been a number of initiatives that he has led, so this should be a really interesting talk about how he maybe is bringing Lean Six Sigma into Industry 4.0. See a wealth of ASQ certifications there. And today he is the current ASQ Statistics Division Data Science Interest Group Chair. So with that, we will turn it over to you, Michael. We look forward to hearing what you're going to share with us today.
Thank you, Barry, for a nice introduction. Let me just share screen. Do you guys see my screen?
Yep.
Good.
Yes.
Okay,
Looking good. Thank you.
Check once again that I have, yeah, okay, it's all good. Sound is shared. Okay, so good afternoon and welcome to my presentation. My name is Michael Mladjenovic, and I am a chair of Data Science Interest Group. As I mentioned before, I would like to invite you to join us. There is no cost for ASQ members to join. You can send at the end of the presentation, there is my ASQ email, as well my personal email, or you can join me via LinkedIn or join ASQ Statistic Division Interest Group, Data Science Interest Group on LinkedIn. So what I will be talking today is kind of, it's a living presentation, as Milt mentioned, and I will try kind of to fly like a 60,000 feet high and talk about how we create value from the current knowledge that organizations have, as well kind of from learnings coming from Industry 4. Let me just second. Let me just kind of okay, doesn't matter. I will start with the first with the technologies, and then I'm going to talk a little bit about big data, processes associated with Industry 4, tools associated with Industry 4, maturity related to application of Industry 4, and I'm going to finish how to use Lean Six Sigma and data mining tools to create value for organization. It's in a way to immediately create value. Majority of Industry 4 projects, they don't create immediately value. And my intent of this presentation, and couple more which will come down the pipeline, is to democratize Industry 4, Quality 4, and remove that barrier that I felt 2-3 years ago when I jumped on Industry 4 transformation and learning about Industry 4. So democratization, what I will present at the end, just a way how you can apply data mining, very easy using Excel add-on. And that's kind of which pulls some R subroutines and Python subroutines. When we look at the implementation, many organizations, especially small and medium organizations, struggle how to implement Industry 4 and how to do the transformation. Although they are using some tools and they just need to jump into cold swimming pool and start to swim in Industry 4. So purpose of presentation is to give you some thoughts and some ideas how we can create action based on synergy between Lean Six Sigma and how to create value for organization. So what I will do, I will start with a quick overview about what Lean is, then what Six Sigma approach is, and then talk about the different technologies that are available for us in Industry 4, and then build that all together. So when we talk about Six Sigma, Six Sigma represent many different things for different people. It's a excuse me, management methodology. It can be metric methodology and tools. So according to ASQ, Six Sigma is defined really kind of very clearly, but Six Sigma means different things for different people. And when we look kind of now parallel between Six Sigma and we look at Industry 4, Industry 4 represents advanced digital technologies with quality excellence to drive substantial performance and effectiveness improvement, according to ASQ. So when we look at the purpose and the goal of Six Sigma and the quality 4, they're pretty much the same. So difference is really kind of application of some tools which are usually uncomfortable at the start, and then as you start to use those tools, you see kind of really that they're very simple. I had the privilege to be part of initial deployment of Lean Six Sigma in General Electric back in '95, and looking at the whole deployment of Six Sigma and how it was happening helps me really to build a parallel between implementation of Lean Six Sigma and Industry 4 integration. So when we started the deployment of Six Sigma in '95 with General Electric, Six Sigma was driven mainly by statisticians. And to make a parallel now, kind of we have a data scientist. And usually science and a business value, they're not very well aligned. It's really kind of, you want some practical. And if you look what Six Sigma is today, we have a same situation that pretty much everybody is doing Six Sigma. The only difference that I see, so this is similarity, that path is the same. What is different is speed of change. So it took some time to different organizations from Ally Signals and Motorola kind of moving into General Electric when it was really kind of started to become linked with the business. Took some time to embed in organizational DNA and remove fear from what Six Sigma is. And then we came in 2000, and there were, well, a little bit before kind of, I know we had a dialogue within ASQ, do we need Six Sigma in ASQ or not? And some people had the opinion, well, we have a quality engineers, they use statistical tools, it's the same. They didn't get that Six Sigma is really applying a statistical approach and scientific approach to solve business problem. And quality engineers were doing the same thing, but it was really related to quality. It was not driven by management people who are doing work. And another thing, what was happening, the Lean requires different way of thinking compared to Six Sigma. And it took some time for people to learn two different way of thinking, and similar like six thinking heads, and being able to jump from one way of thinking to another. And then same thing what came Industry 4, and now we need to start to think in a I'll call that a digital way of thinking, and understand the different types of data and ways how we can create value. I'll have a couple slides after that talking about that. What is interesting that the Lean transformation, which consists of purpose, process, and people, now kind of switching slowly to add platforms and programmability. So purpose stay the same for organization, but the business processes in Industry 4, they're starting to change. And one thing, if you don't have solid processes, well-defined using lean, and if you don't have statistical thinking, and I'm talking about statistical thinking, I'm not talking about statistical accreditation or kind of being statistician. I'm talking about statistical thinking, being able to understand that each process has mean value or median value and variability. And if you understand that and you have a clean data, you can start to make magic. You can start to improve your process. And you use different software tools, Minitab, Sigma, Excel, name it, to do work for you. And you're the one who understands business problem, who can ensure that data are clean, and then start to move that data in a software and do interpretation and take action, and by doing that, make value. When we look at the data scientist, I would make parallel kind of between statisticians, although I'm part of statistical group and I have statistical background, and but parallel between data scientists and statisticians, they didn't feel very comfortable with business problems. They have a different way of thinking and a different way of behavior. So what we need is to break current big problems that data science is trying to solve into smaller problems that management and front-end people can solve using democratized tools, which are easy to use and solve their day in, day out problems. And when we look at that whole transformation, we need to understand really kind of how Industry 4 came into play. So starting with Henry Ford in 30, when he started really kind of lean in some way, but I didn't find in any book, in anybody that talk about why Industry 4 happened. And the Industry 4 or lean, why lean happened? Lean happened because complexity of the processes, material and information flow. You had a mass production, and now you have material and information flow complexity, and you had to implement lean to empower people and remove waste. And then in the 80s, associated with Industry 3 came Six Sigma. And Six Sigma came from complexity of the products or processes where you had to have high raw throughput yield and kind of make sure that each of elements achieve certain level of quality to allow for flow of information and value throughout organization. And then in Industry 4, we have complexity of data. And when I talk about data, which are available to create extra value for organization, because when we look with the Industry 3 and Six Sigma, we can mainly deal with structured data. We cannot deal with unstructured data, which is 80% of wealth, which is available for us to discover way to create value within organization. So why Lean Six Sigma practitioners are really kind of in a great position to, and a quality professional, why they're in a great position to move into Industry 4. First thing, maybe I should mention why they are not moving, because they have a fear of unknown, fear of failure. And I have a PhD in a kind of business and mechanical engineering. And I had the fear 3 years when I was starting this journey. I didn't know where to start. But advantage of Six Sigma practitioners, Lean Six Sigma practitioners and quality practitioners, that they have domain knowledge. They know business side of the problem. And when we look at the math and statistics, which is two, they have some knowledge there as well. which positioned them very nicely to move into area 4, which is Lean Six Sigma. And this is where we are now, kind of last kind of 3-4 years. Now, where we need to move from here in area number 5, which is kind of data cleaning, managing, as well kind of business intelligence with descriptive statistics, sharing kind of where we are with our processes. And once when people overcome that, quality professionals, they should really kind of try to move in area 6, which is machine learning, which is really easy. Because you cover regression, you cover ARIMA, you cover time series analysis, you cover logistic regression. So there are a couple more tools and methodologies which are very easy to learn, and you don't need to learn programming language to use those tools. Because now even Minitab, JUMP have those add-on to data mining and solving kind of problems using data scientific knowledge. So that will move quality professionals in area 6, and then you can incorporate the kind of overall kind of data science. Computer science is optional. You really need to have computer science expertise to be able to drive software which can give you solutions to problems that you have. So let's kind of drill down a little bit into Industry 4 technologies. And this is really kind of why people get scared, because you can start anywhere. You have industrial Internet of Things, you have robotics, you have computing, you have 3D, augmented reality, different types of simulations, optimizations, and big data. And really kind of people usually start to look at this big elephant, and like 7 blind men, you get some webinars, some information, some books, but they're related to different elements of this big picture. And they struggle really kind of how we are going to get there. And one way kind of for us as a quality professional is to look at the, I'll call it traditional data that we are looking quantitative and qualitative, and look at that another chunk, other, which covers almost 80% of data which are available for us to draw conclusion and make improvement. So when we look at the big data, it's about complex data sets. However, you can apply all that methodology on a small data sets. And I have been working with a couple of clients in the States, training black belts, and they have now data mining as a part of their program. And we're implementing in a projects and finding solutions to the problem, different data mining techniques. And why is that important? One thing which is really critical is to understand that retention of employees today is very low. In the past, people were staying 20, 30 years with the company. They would observe different changes which are happening, and they will start to build hypotheses or relationship between different events. And when we would start Six Sigma project, we would have a team of subject matter experts who will help us to build something what we call driver tree. What are the things which are potential? And even when you do problem solving like a fishbone, you need subject matters to help you to build that. Now, what will happen if you don't have subject matters? What will happen if your turnover rate is 3 years and you don't have those experts who had privilege or advantage of observing process and slowly establishing some relationship. So that's kind of one thing. And second thing is, what will happen if you're looking at a process which is a black box for you, and people cannot observe that process? How you're going to, you have on your disposal scientific literature and stuff like that, but you don't have on your disposal to see what are the key drivers for your process. And with the, let's say, principal components analysis, with the very simple tools, you can very quickly see what are potential driver in your process. Using classical statistical tools, there is too much noise, and you cannot really get that quickly through dirty data. Majority of statistical tools require the relatively clean data. When we do data mining, we do cleaning of data. We take outliers, we take hot link T kind of to separate what is noise, what's not. But your data is still dirty, and you have so many different variables which would create too much noise when you use a classical statistical techniques. And so that's one thing why you use that. On other hand, amount of data that you have, their volume, their velocity, variety, veracity, and the value which is there, that value is tremendous, is really kind of on our disposal. And this is really kind of where organizations, like it or not, have to move and start to tap into unstructured data which are available. And almost 80% of that data is unstructured that we have. 80% of data that are available are unstructured data. And you cannot use classical Six Sigma or lean tools to tap in that value which is hidden. So you like it or not, we'll have to move and tap into that area in Industry 4. Now, what's a beauty is when I look data science model and DMAIC model, they're pretty much the same. And I'm going to show this. There is very small difference between those models. In DMAIC model, or DMAIC if you want, you define and then you use in measure. Big difference is that in DMAIC you want clean data. Another thing is a similarity between data mining and the Six Sigma is a sampling. So in data mining, you do sampling for different purposes, for the purpose of validating your model, how you break your data that are available, build a model, and do validation, verification of your model. In Six Sigma, you sample, and your sample has to be representative of your population, big requirement. In data mining, by having different combination of different sub-sampling sets, you're able to overcome that problem. And analysis is pretty much similar. You want to see kind of what's significant, what's not significant. Now, the problem is with improve, it's where you start to implement those changes. And this is, in my opinion, I can be wrong, is kind of where whole Industry 4 is having blockage, because in Industry 4 you have usually business analysts to define and translate business. First, you have a business owner or process owner who, if they don't know thinking associated with Industry 4, cannot articulate properly their problem. Then you have business analysts who translate that problem into data science problem. And then you have data scientists who doesn't understand business problem trying to find solution. And that solution which is created, then it's transferred to people who have to implement and control that process. And in addition to that, those whole problems that we have, they're extremely complex. So what I have seen so far, that it works extremely well with the big companies which have huge amount of resources, and as well extremely well with the areas which were not tapped before, like at the level that data science allowed, like a marketing and sales, kind of with the unstructured data to do link with the different personas, link with the customer journey, link and utilize that to improve customer experience. But when we look at the process mining and the application with industry, only big companies, they have enough resources to invest in infrastructure as well as resources. And more kind of bigger problem is investment in resources than infrastructure. If we look at the CRISP methodology, which is data science, it's the same as the DMAIC. You have a business understanding, you have analytic approach, you have a data cleaning and requirement data collection understanding, you have data preparation, and you build a model, and then you deploy model. You have a feedback, and then you maintain your model. So there is, in essence, when I look at the DMAIC and a CRISP model, there is very small difference. Methodology, and it's really kind of application of scientific methodology. If I look at the CRISP methodology, it's same thing. It's kind of business understanding. If I look kind of determine business objective as a situation, determine data mining goals, produce project plan, it's defined phase. It's not big difference. And the same thing, data understanding, collect initial data, describe data, do some visualization of your data that you have, do data exploratory analysis, verify data quality. This is exploratory analysis that you do with the DMAIC project as well. You look at distribution identification, you look at any outliers, you look at how your data behave over time, you look at autocorrelation, you look at a whole bunch of technical things to see kind of what's the quality of my data, and so on. But bottom line is kind of when we look those two methodologies, they're pretty same. What is scary is data mining paradigms and tools, and I cannot even read these slides, how many tools are there. And now becomes question is really kind of, there is no, with the data mining so far, and I can be wrong, there is no clear roadmap like you have with the DMAIC. You start with the project definition, you build a charter, you do your kind of initial kind of basic statistics and graphical summary, you build a box plot of your data, you look at the run chart, and you then do your measurement system analysis, capability study, and so on. It's really kind of, it's a little bit scattered. Maybe I didn't learn. If somebody has a solution for that, it's kind of, I'll be kind of interested to hear. But the problem is you have so many different tools. Way how those tools are taught at university is kind of, you know, to know kind of vectors, kind of matrix analysis, you need to know tensors, you need to, and you need to be a scientist. So question is how to simplify this and make it practical so people can take action and create value for organization. I'm not going to go through different tools, but list is huge. And people kind of get scared when I see this. I start to look kind of where I should start, how I'm going to learn this. And I had that issue 2.5 years ago. It's really simple, but you're talking with the experts. Try to talk with some statistician about some problem, and you will get really kind of bugged. You know, it's kind of, it's scary. And there is no simple explanation, although whole data mining is pretty much simple. You have two approaches. One is supervised learning, and second one is unsupervised learning. And in supervised learning, you know how your output Y looks, and you have different axes, and based on that, you're building your predictive model. So I know what is a hen, I know what's not hen, and I have for each I have first picture, I know that's a hen, second picture, I know that's a hen, third picture, I know it's not hen, fourth picture, I know it's not hen, and based on that, I build a model. How you build a model? Now, there is a kind of science and art, how you select the different tools which are available. I don't want to oversimplify. But how you build a model, do you need to know all math? No. You need to know how to prepare data and what to do when you find out that something is hen. Unsupervised learning is a higher level kind of learning where you have a different pictures, but you don't know that first one is a hen. You don't know that second one is a hen. You don't know the third one is a dog. You don't know that fourth one is cat. And what your kind of algorithm is helping you to extract features which are unique for hen and do clustering of those features to have this is a hen, this is a dog, and this is a cat. And this is what we are using in the black belt projects currently with the supervised and unsupervised algorithms to identify key drivers for our process. And then you need to make through measurement system, and then you jump back into your measurement system and say kind of how I'm going to clean my data to have really kind of better signal to noise ratio when I build my model. Now, to move further, there is a machine learning and deep learning, and in data science, they don't call kind of variables, they call features. And the kind of feature is a characteristic, and I'm just kind of thinking how to simplify and not lose it. And you can combine feature, and there is a whole area of data science which is called feature engineering. You can combine two features to get artificial third feature. If I want to make parallel when I talk with my students, I usually say kind of almost like for quality professionals, interaction between two things create another feature. It's kind of, if some statistician or data scientist hear this, they would probably kind of kill me, but I am trying to simplify very complex things so people can digest and they can remove fear. Because fear is the biggest obstacle that we have, fear of feeling kind of, I can't learn this. Well, you can. It's very simple. You have just overcome fear and start to learn. And we have machine learning where we have kind of people still doing feature extraction, and then kind of your computer will do, and the software will do classification. And you have deep learning where it's totally kind of feature extraction and classification. Usually we use in the neural networks, which are doing that for us, are really kind of based on output that we have data, raw data, can draw conclusion, is it a car or not? Versus in machine learning, you have a raw data, and we need to identify features, and then classification will be done by your computer. Now, this all is available. This is a Minitab output with a classification tree. And there is kind of, you can look kind of which are kind of variables and importance of different variables. And this is what I say, kind of, this is just one of the tools. Minitab has now a prediction add-on, which is not part of standard Minitab, which does a whole bunch of different analysis that you didn't have in the past. And this is what we are, either this or we use the principal components with the different software, which is called Simca, to identify really kind of what are the key factors. If you cannot see your process and you don't have a subject matters, you can use this to identify your key factors. It's really kind of, you look, I'm not going, this is from Simca output, where you look at which are the factors opposite to each other, which means that they're kind of having different influence on your model, or which factors are on your kind of principal component is kind of further from the center. If you look variables which would be here in the center, those variables are not significant. If variables are further associated to principal component, and you can read very quickly that age, this is a blood pressure example, that age, blood pressure, and the diastolic blood pressure have a highest impact. So you can read, you don't need to become car designer and scientist, data scientist, in order to use this. Now, that brings us to last kind of segment, kind of talking about organizational maturity. And when I look organizational maturity and value creation is really kind of, majority of organizations have descriptive analytics, and you can do this with even Excel without no problem. To do a diagnostic analysis, what happened, why this happened, and establish some causality, you need to have statistical software. And this is an area where still Six Sigma operates very well. And then to do predictive analytics to certain portion, this is still Six Sigma. The only constraint is Six Sigma doesn't work with unstructured data. So if I look kind of two streams going, Six Sigma will cover maybe three, even portion of the fourth one, because if you use a Minitab, there is an optimizer which can look at the multiple inputs, multiple outputs, and optimize and do prescriptive kind of but on your structured data. Now, if you have unstructured data, you will not be able to use just classical Six Sigma tools. You need to have data science there. So that's a big jump and big learning. But to move into deeper, really kind of prescriptive analytics and cognitive self-learning, you need data science. Now, within your organization, when you look at the maturity of organization, you don't need, well, your maturity is not consistent across different functions within organization. So you have to make decision when you deploy this to understand really where we are currently and where we want to be, but it has to be based on different areas and a need for application and value, immediate value creation. And you can start to create value from data science very quickly. And everything is really kind of associated with your value creation and how much involvement from people's size you're going to have. So there is kind of a same kind of a diagram, but key is kind of how we are using today, or do we use any Six Sigma for our decision making? Do we use the Lean to standardize our processes? Because Lean standardization is required for data science as well. For Industry 4 processes, Lean is required. In addition to that, I have seen many organizations applying automatization on the processes which are not streamlined from a Lean perspective, and they start to create garbage faster. Or even worse, garbage is non-value-added activities are now hidden within computer program, and it's less visible to take action associated to those ways that you have. So these are some perspectives. Now, how we can use this? We can use first, starting with the Cannon analysis, to look at how market performs and coming with the creative solutions. What are the features of our product associated with the future and current deployment that we should improve? We can use for the customer journey. We can use data that we get from the data mining and classification and clustering of different segments of our customers and creating different personas. We are creating in marketing personas, but use data science to create personas and create individual customer journeys for different personas that we have. And individual Cannon analysis, because when you build Cannon analysis, you don't build for people who are teenagers and people who are 65 years old. It's not same Cannon. And now you can deal with the average, and then you lose kind of advantage that you potentially have. With the data science and ability of computers to address that, now you have advantage that you can very quickly come with the results or tap your results in a benchmarking and VOC for QFD, or looking at the Net Promoter Score. Many organizations now are using data mining for a Net Promoter Score. So it's not just to measure your Net Promoter Score, but understand which segments and establishing features of those different segments which are driving certain satisfaction with your product, or to look at the different tools that you have. At the bottom, I have kind of just a scorecard or display, which is a standard output, which you can get with Tableau, with descriptive statistics, which is not predictive. Although even business intelligence software is starting to move into deep data analytics. So Tableau, what we see in the market, Tableau is starting slowly to move into data mining, although initially it was just basically kind of for business intelligence, pretty much for reporting and consolidating data. How you can use that is now you have a wealth of structured and unstructured data that you can link from your product to your process tree. Something what axiomatic design was doing, but at much more complex and higher level. Another thing is kind of what I was talking about, what we're already doing with a couple clients in the States, helping with the driver's tree. In the past, we would use cause and effect matrix. We would use subject matter expert knowledge to build a driver tree. With the data mining that I'll show you with Excel, you can do that extremely quickly and not expensively. You just need to create that learning so people can do. Or building based on data that you have, link your building value stream mapping based on data. So question becomes really kind of how my Lean Six Sigma process or things that I do can be augmented with data science. So your solution is going in two ways. You're looking how I can apply Lean to data science and Industry 4. So implementation of Industry 4 and Quality 4 is successful, and how I can utilize Industry 4 technology, tools, and methods to enhance what we are doing during the problem solving with the Lean Six Sigma. So it's really kind of it's very complex, and it takes some time to learn. You can use significant, you can make significant impact with your risk management using data mining. Think about FEMA that you're doing today based on expert opinion, but if you don't have expert opinion, how are you going to get your data here. And this is really kind of a big issue that we have. And that brings us kind of to the short presentation of how you can do data mining using just simple Excel add-on. So let me, hopefully it's going to work. If not, I will have to. Let me just see. Hi, welcome to the short data analytics presentations. We're going to use a very simple model where we have output delta in a pulse, and we have 6 inputs. Some of them are attribute, qualitative inputs, like run, smokes, sex, and activity, and some of them are continuous variables like height and weight. We're going to go through the different data analytics methodologies and some data mining methodologies, which are easy to complete today, even using just a simple Excel add-on. So once when we have data, we need to put data in software, and how we do that, we put kind of select tools wizard. And what we're going to do is create a model. How we do that, we select tool wizard, and we're going to go first with the regression and see kind of what kind of model we're going to have. And we know that we have in our case 6 factors which are affecting our model, and we want to show predictions just to confirm our R-square value, our sum of square value. Then we look at the data, and the first thing what we do, we select our output Y, and then we're selecting our continuous predictors, height and weight, and categorical predictors, which is run, smokes, gender, and activity. Based on our data, those are categorical factors. And once when we have that, we just click OK, and we wait. So now we have a standard output for regression analysis. So if we go to our data pulse data, and we copy that data, and we compare that data with our prediction, and then we want to calculate our difference between prediction and our model, we got that as a difference between prediction minus model, or model minus prediction. That doesn't matter. And we have this data set here for our really residuals. And if we want to calculate our sum of square, that's equal to the sum product of this column, which is really squared values. And this number here is the same number that we have for our residual sum of squares, 7,127. So that's an error that we have relative to our model. So let's try now some different model. So we're going to pick up tools, and we're going to go to analytics and go with non-parametric prediction models, and we're going to pick up, for example, decision tree. And there is lots of different models that we can use here, but let's pick up conditional decision tree, and we're going to keep here kind of all setups standard. Click on data. We are going to select the pulse as output, and all these elements here as a factor variables, and then we're going to click OK. And now we're going to have our decision tree, conditional decision tree, and if we go to our regression and copy these two outputs and put in conditional tree to see kind of quality of this model. If we go to our regression tree and we copy this data that we have, which is going to give us residuals for our model, if we paste that data, we'll have with the decision tree model error, which is equal to 6,000. And we continue as we go to build a model, we continue to build the different models. So we can select as a next model, for example, neural network. Now, what we can have all setups defined by the software, or we can define, for example, hidden layers to be 3. And then we just have to do selection of our data, response data, factor variables, and we click OK. So now we have a model with a neural network, and what we can do, as we do with many other methods, we can look quality of the model. So now if we calculate residuals, we can see that our residual sum of squares is 6,000. Now question becomes, can we improve that model? And let's see kind of what will happen if we have 3 hidden layers versus auto. And now what we can see with the 3 hidden layers, we have improved our sum of square to 5,500. And the last model that we're going to look today is if we pick up model, which is XGBoost. And we have the same thing. Again, we do the same thing. We look at the data. We select response variable, and then we select factor variables, and we click OK. And now we have XGBoost model here with the prediction, and if we copy our model things and we apply to XGBoost model, we can see that definitely this model is superior in this instance to other models, parametric and non-parametric, giving us sum of squares which is 32,073. To summarize, when we have a data and we perform data analytics, that's an iterative process which requires hard work and understanding of framework that we are using to develop our model. There is no one solution fits all. You have a different algorithms, different methodologies that you can use to perform your data mining. You can use parametric models or non-parametric models, and you can use data for training and then data for validation, for testing. And based on quality of your model, you are going to select the best model. So during exploration, you use different tools and methodologies, and one size doesn't fit all the problems. As you build your experience with the specific models related to your specific application, you're going to converge towards the models which are more effective in your area that you're doing your work. So this was a short presentation. Thank you. Any questions we're going to answer at the end of the presentation. Hi, well, okay. So that's I don't want just to send the wrong message to say that data mining is this easy, like I show here. So it's not this easy, but you pick up easy way to learn. And there are easy ways that you can learn and grow your knowledge. How you do really data mining is not just one step. You have a different subset, and you have a sampling in data mining as well, like you have in a real life. You just sampling kind of what will be used for the model, what for validation of the model, because you can overfit your model and stuff like that. But what the purpose of my whole presentation is really to understand that there is a synergy between Lean and Six Sigma. Lean Six Sigma, in data industry 4 in data science, Lean Six Sigma can be used to support the deployment of data science in industry 4, as well kind of tools and methodologies can be used. This is a process and it's hard work. Gartner has developed hype curve, which really kind of people, consultants come and say, this is easy, you buy this, or this is all, and this is not how it works. And we have all went through that with the hype with the Six Sigma, hype with Lean, hype with ISO, hype with this. Everything is hard work, but you should look for sources which are going to help you to grow and support. And our data science interest group is one of those. There is no cost for that, and it's a great group of people. But as well, kind of start your journey. If you're not on journey, don't be afraid. There is a lot of resources within ASQ who would help you. The problem is, try to get in contact with somebody who has been already on a journey, because if you go alone, like with Six Sigma, without a coach, with somebody who will help you to know exactly how to go, kind of your path, you will get there, but path is going to be much longer and much harder. So this is the end of my presentation. It's still work in progress. Probably kind of by World Conference, it's going to be even better, and have a new things and new learnings that we are experiencing. Thank you. Any questions?
Thank you, Michael, for, and I'm glad you sort of clarified at the end that it wasn't just so simple, that there is some work to do it, but demystifying places for people to start. I think what we want to do is bring Milton back up onto the stage with you to help facilitate some of the questions. There's some great questions and some great comments coming into the chat. So Milton, are you there? I don't see you.
He's there. I see him.
You see him? Okay. He's having microphone issues. So
okay.
We might be able to help moderate some of the questions until he's able to get through. Let's see here. Sounds like there was, I'm just going to go up to the top while we're waiting for him to come in. Or Topher, do you want to?
Yeah, I can.
Okay.
Sorry. I was trying to do a share, but I was having a little issue, but it's fine. We already introduced Milton earlier.
Yeah. Milton's our best friend now from the day for the,
yes,
sponsorship and should be an interesting conversation. So I hope that his microphone comes off, but we do have some questions that people have posed. So go for it.
Yeah. We'll try and troubleshoot what's going on there with that. One of the questions I had actually, which is kind of, I know you mentioned this quite often about the complexity of some of this, data science, AI, and how it's almost like there's more of a stigma than there actually is the complexity it takes to learn some of these skills. And I'm just kind of wondering, based on some of the quality engineering stuff that we learn in our toolkit, what is it we could do to try and convince quality engineers that they really can tackle these topics and provide insights by leveraging their current skills to help contribute to some of this stuff?
I think what we have, and I'm just going to jump into data science interest group, that we have a journey. It's a playground, and it's a playground. Milt is there, and other people. We have kind of statisticians from university. We have people who never took statistical course, and they're talking. So we're talking. We when we come to have a session, we don't know exactly what we're going to talk, and some of us prepare something, and that start dialogue. So what I would suggest: create your learning group, and or playground, and it's best if people are equal, if equal level of knowledge. But doesn't matter if somebody is there, but you don't want a dominant person in any dialogue. You want a playground where everybody will feel free to say and learn from each other. So tap it that playing arena and start to learn from each other, because then you multiply your learning. If a group is like 10 people, you multiply 10 times your learning, and different people discover different. Again, there is so much information and you get lost. So by doing this, you have 10 people digesting and 10 people preparing learning for you. So get a group of people, start to learn. Look for the mentoring if you want. With the human resource group, we have published 2-3 articles about the playground. So what happened is kind of 4 years ago, we started with the really 3 years when there was digital, when we got Corona, quality professionals didn't know how to work online. So we create playground to learn how to use a WebEx together. And there are different people. And when we started that, as being a kind of instructor and professor, I had a tendency to tell people what to do. And I had a great coach, and she said, you cannot do that. You're going to lose people. And so I was there just if they pull me, but they were playing, learning together, and they learned. And we published 3 articles in ASQ HR magazine. And then I said, well, we have another problem, how to learn data science, and let's start a group. And we started, now it's 2 years. We meet every Saturday at 10 o'clock Eastern Standard Time. And, we came with at least, I think 7 presentations. We partner with the Canadian region, and maybe we'll partner with the Pacific region if you want, which means we provide some speakers and we have a webinars jointly and bring some data science topics to different areas. So who knows, I am looking forward if you guys are interested to build, and some people to join our interest group. We have around 170, 180 people, but the core group is like 12 people who are meeting, and we are building webinars and sharing. Our mission is to create a bridge between to quality 4 and industry 4, and it's a learning journey.
Great. I think we might have Milton back with us. Milton, can you hear us? Oh, maybe we don't.
Yeah, I'm not sure what suddenly happened on that.
Something, he dropped off for a moment. So I guess we'll keep going.
Yeah, and again, if there's any other questions, feel free to shoot them in the chat. I guess looking at some of the stuff that you were talking about there, for me, working in big data, strong data governance is really something that is lacking in a lot of these different companies in order for us to have really good data quality to get the most out of these kind of models. And I really feel like it would be nice if we can use some quality principles to drive the data governance from the beginning. And when I saw some of the CRISP architecture, for instance, for making these data models, it reminded me a lot of the waterfall methodology suggested. I used to work in med device, and so we had the 21 CFR 820, gives guidance on this waterfall device development methodology that a lot of people use. And seeing those parallels makes me think that maybe that's something that either you've seen people do, or maybe that's a suggested way of kind of tackling some of this data quality, data governance issues that I think quality principles would be perfect for.
Yeah, beauty is that quality principles can be applied to anything. And I think that there is a mistake to talk about quality for. It's really kind of because quality is going through transition, and function of the quality stay the same. Only kind of tools that we use are different. So kind of we have to think really kind of what we are currently doing, what are available tools, how I can educate myself and work with other colleagues to understand what are those new tools. That's really kind of the only difference, because the function of auditing will be the same. The only thing my auditor can say, okay, let me look your data lake, let me look at your governance model, how you protect your data, let me look at the how you integrate your supply chain with data and stuff like that. One thing which is interesting that I think this year they didn't award the Baldrige Award. And I mentioned kind of Industry 4 data, Industry 4 excellence models. I think that there are next things which will come. And they're not prescriptive models. They're not models that are compliance. They're models which help you to build your stronger quality management system. I know that European award is going through transformation. I'm looking to see kind of what Baldrige is doing. As I mentioned, kind of they have a Ravi model in Germany. There is around 43 models now kind of working around, and one is a series with Singapore, which is easy to digest. And easy to implement. And again, it represents education of people within organizations, self-assessment, and building roadmap to digital transformation.
Yeah, I totally agree with that. You know, I think when people say it's, you know, quality 4.0 and everything's different, it's like exactly what you said. It's the same thing. You're just using different tools and applying it to different things. You know, it's like moving from med device to aerospace to manufacturing. It's same quality tools. You just got to figure out how to apply it to this new technology.
Yeah, exactly.
That's awesome. I think Milton, are you able to join in now?
I'm back, but I have an echo. I have an echo on everything. Everything's coming right back to me. I'm still trying to sort through that.
You know, you have to turn off the sound on one of your devices.
I only have one device.
It looks like you're showing up with two on the screen.
That's what it's telling me. One of them's failed, but I only have one device. And it says I have two microphones going now, so I'm still trying.
No
Okay.
worries.
We can hear you without an echo right now.
But I can't talk without hearing the echo coming right back at me.
Yeah.
Right.
Let me try a little bit more here, but
Okay.
I'll try to get back in a minute or two. I don't know what's going on.
No
Okay.
worries. Understood.
There we
Hey,
go.
Milton, are you still getting an echo? We lost him.
No, wait, I'm back.
Oh,
No
hey,
echo.
there
No,
you go.
hey, the echo's gone now. It's clear.
All right.
Okay.
Did you have any other questions to help guide the conversation a little bit before we do the final comments?
Well, I missed the questions there. I'm sorry. Everything was
No
going
worries.
well until I went to unmute and chime in at the end, and it said I lost my microphone, and the Zoom wasn't responding, and I've been in and out several times. But what I wanted to add, and I hope I'm not repeating anything, I don't know if we really got into a lot of detail in my session or Mike's session, but I don't know if you picked up on it. Mike and I are on the same team on the statistics division discussion group. And we're kind of going down different paths toward the same direction here. You saw a lot of complementary discussions back and forth. And I think that we've come across a common theme that the ASQ or the QBOC, the body of knowledge, is in place, but it does need revision. It needs to be amended, needs to be edited and modified so that it can be more relevant to our current situations where we are today. And the nice part about it is, and Mike really didn't take credit for this like he should have, but leading this discussion group, he's got a fantastic team. As I said, I'm one of the team members working for him, doing this research, and we've put on an entire series of webinars this past year, all on topics related to this in various industries. So we're trying to raise the awareness right now and move forward. I think the future looks bright. It's challenging, and there's a lot of opportunities for us there. So Mike, great presentation. And by the way, we did not collaborate when we prepared our presentations. There was no discussion at all. I've been on travel quite a bit. I know Mike's been busy, but I think we complemented each other very well here. And that was not planned. It's just the fact that we were both very involved and very dedicated to statistics and data. And we want to see that Quality 4.0 supports Industry 4.0. So I think you've got four excellent presentations today. I'm sure the last one will be as well. And Mike, thanks. Great job. I'm sorry I missed the questions that were directed from the group here. By the way, when I log back in, my chat room is empty. There's nothing in there. It's all gone, everything. So I got a fresh start. So I couldn't even look back at the questions that were posted, but I'm sure you did a good job responding to them. So I really don't have anything else to add at this particular time. I don't know how we're doing on time. I guess we're okay, aren't we?
Yeah, it sounds like we could use some data quality on Zoom's end, perhaps.
Yeah.
I'll tell you, I've been using Zoom for about 3 years, and that is the first time I've encountered any problem like that. And everything was looking well until I clicked to unmute my mic, and then I lost it.
Yeah, sorry about that.
So I apologize for that.
Do we have any other questions in the chat, or anybody who wants to come off mute to ask one?
I don't know, did anyone ask Mike the question of, what do you think? We've got a lot of good information here. I think that there are 50 some people attending this presentation will agree with us. But what do we need to do to raise the awareness issue and to start with more implementation of this, more in the practical side? Because it does provide opportunities for improvements that we're missing right now.
It's the same thing when I consult my clients. Start small, and that's the first thing. Start small, build good partnership, and even build a partnership if people are not more knowledgeable. Don't be alone in this journey. This is and whenever I was close to fail with my project, it was based on change management, and I didn't talk about change management. This is just I hope that I didn't scare people with technical side, but everything is about people and how to engage people from the middle management to top management. How to, if you go to Siri assessment, you look at how educated people are, kind of what Industry 4 and Quality 4 is, and how to, and we struggle to define what Quality 4 is. You know, it's really kind of, I don't see big difference, just the method. It's meeting or exceeding customer expectations. Just the method, how you do that is different. So I think that it's a big learning, and Mill did some great work kind of to provide the ASQ leadership team with some path going forward and stuff like that. But it's discovery, and don't be afraid. Don't have a fear. Join some similar minds, and just, this is journey. You know, feel comfortable, play with that. You know.
So
yeah, I'll add one additional comment. I overlooked this morning with my presentation. There's a magazine called Quality Magazine. It's not an ASQ publication. Quality Magazine, I don't think it requires a subscription. You can access it online. And in the December edition, I wrote an article, speaking of quality, is anybody listening? Quality 4.0. And I was limited to the amount of words that they would accept. They told me that it's published. It'll be available in December's Quality Magazine. And it kind of is an executive summary of what I presented here today. And is designed for business managers to become more aware of how quality can assist in processes and what Quality 4.0 is all about. So I encourage you to look it over. It only takes a couple minutes to read. It's not a long article. They didn't have a lot of space for me, but I think it lays some good foundations there for moving forward.
If I can add
Sure.
to what you're saying, this is CG. I would like to say that Akhilesh, who is our programs coordinator, not programs, but the workshop coordinator for Pacific region, can bring Mike in for a 4-hour or 6-hour workshop to help people on the West Coast or West region, and be very useful learning for everybody who are interested in this kind of statistics and Minitab.
Sure, sure.
So I would request Akhilesh and Mike to maybe exchange your emails and see if it's possible.
Sure.
Akhilesh, are you there?
We'll be glad kind of to include a couple more people from our group and do some work. That would be great. Yeah, sure.
Yeah, I know the webinars that Mike's organized that we've done this year probably reached a couple hundred people, at least 250, 300 people. And the feedback seems to be positive. No one's come back and said, you don't know what you're talking about. This doesn't make sense. You're way off base, or you're just trying to publish something that looks glorious, but real no practicality to it. The feedback that we've been getting has been encouraging. Let's put it that way. Very encouraging.
Good.
Anything else? Anyone else? Anything?
Akhilesh is on with us today. I think he can throw some light what his thoughts are. What do you think, Akhilesh? Unmute yourself.
Hi, Mike.
Hi.
We were having a chat during the break, and although I wasn't referring to this portion, and we were just talking about various constraints and trees, so because I was curious, something I did. But I think this should be a great session, and we plan on, I'll give you a call. So we'll see what are the right dates to.
Sure.
We are thinking on probably 1 or 2 hour sessions a week.
Sure. Sure.
And over 5-6 weeks.
Good. Good.
I'm sure I'll be able to get you. Well, I've got your email address and I'll leave you. So.
Sure. Yeah, you can use my on the screen, and Christopher and CJ have that. So it's yeah.
Okay.
Awesome.
That's
Thank you.
great. Any, no, do we kind of scroll through? I don't think we see anything more there. It sounds like there's some great offerings about this group. And any kind of, especially Mike, any last words you want to share with us?
As I say, kind of everything that we do happens twice. First time in our head, and then in reality. So don't be scared to dream that you can become data scientist or kind of, and it's not hard. There is a help. There is a within ASQ that and connect with other people and just jump on the journey. Don't wait anymore. I was waiting. As you wait more, kind of, and it's a it's a journey, and if you have a great team, and I was extremely lucky to run into great group of ASQ professionals that we're learning together, and I call it kind of learning. I don't. I have a lots of experience and knowledge associated with data science, but I don't consider myself that I have learned. I can say that I learned Six Sigma, and there is very few to learn more. There is always something to learn, but very few things. With data science, I think that I have a plan for next 5-6 years at least. Kind of the problem is there is a Mortex law. Things are going exponentially kind of up. So I don't think that I'll ever be able to learn everything what's happening in data science, because it's growing so fast, and kind of start moving. Otherwise, kind of gap is becoming bigger and bigger.
And if I could add one more comment to that, this is the educational
Great.
side of me, academic speaking. We had a couple on Mike's team, Mike, the young lady, Lily, that joined. Her background's nursing, healthcare, and she had some good information to share, but she had never done presentations, never did a webinar, was very shy about it, very apprehensive. And we told her that she wouldn't fail because we wouldn't let her fail, that we would stay with her, would stand behind her, would coach her. And during our meetings, she prepared a webinar. She did some trial runs during our meetings, and we coached her. And she did an outstanding presentation. And now I think she's lined up for at least one more or two more. When she got over the hurdle, she did it and finally got comfortable with it. Now she's got some great information about hospitals, what they're doing with some of the hospitals in Canada in relation to data science. And I know her first presentation was fantastic, and I'm sure the other ones will do well. So for any of you that aspire to doing something like that, joining these teams, yeah, you don't get any compensation for it, but you've got to be dedicated and want to learn and have a real commitment to quality in your profession, and get involved with one of those teams. And those like Mike and I and some of the other more experienced professionals are there, and we won't let you fail. We'll walk you through it, and we'll make sure that you do succeed. So that's another good opportunity. That's kind of a supplement to attending these webinars and these conferences, and that get yourself involved with one of these teams and show you have initiative and dedication, and they'll take it from there. They'll push you. We had to give her a couple really hard pushes, but she got it through there, and now she's on her way. She's going to do a fantastic job. So I thought I'd share that with you.
That's great. And so it sounds like that, just a reminder for people, if you want to join this, it's the data science at asq.statdiv.org.
Yeah. You send just email and I'll add you to distribution.
Okay.
So next one is happening in a week from now. I rescheduled a session which was for today. We had a plan to have today, but it would be too much for Milt and myself, and I rescheduled for the next week. So if you send, I will add you to distribution list, and usually kind of day before I send, but it's happening every 2 weeks. Day before I send, and we use the Zoom, same thing what we have here, and
Yeah, it's a quick 1 hour meeting, but we get a lot accomplished.
yeah.
That's great. Well, I want to thank you both again. I know that we want to give people like at least a sort of a 6-minute break to just stretch and whatever as we go into the home stretch. Don't forget to do your survey. It's been put into the chat once again, and we will be ready to go right at 3 o'clock Pacific time.
Yeah. Thank you, Mike and Milton, so much. Amazing conversation, and glad to see such good role models and all that experience going to good use to help out those of us that are younger, newer engineers, or even those just looking to expand our skill sets. So thank you for paving that path for us. I appreciate it.
And thank you for the opportunity to present. Looking forward to work with you guys in the future.
Yeah, absolutely. Thank you.
Thanks.